It is indeed possible to create a function that takes a list of numbers and returns the sum of the even numbers in that list. This can be efficiently achieved using a programming language like Python. Here's a detailed explanation of how to construct such a function. First, let's consider the core logic. The primary objective is to iterate through each number within the provided list. For every number encountered, a determination must be made regarding whether it is even or odd. To ascertain evenness, the modulo operator, denoted by the symbol %, is employed. This operator yields the remainder of a division operation. Specifically, if a number modulo 2 equals 0, it signifies that the number is perfectly divisible by 2 and hence is even. Secondly, we must initialize a variable to store the cumulative sum of the even numbers discovered. This variable will start at 0 and be incremented each time an even number is identified. Finally, after traversing the entire list, the function will return the accumulated sum. Here is the Python code that embodies this logic. The function definition begins with the keyword def, followed by the function name SumEvenNumbers, and a single argument list of numbers enclosed in parentheses. This argument represents the list of numbers that will be passed to the function. Inside the function, a variable named sum is initialized to 0. This variable will hold the sum of the even numbers. A for loop is then used to iterate over each number in a list of numbers. The loop iterates once for each element in the list, with the variable number representing the current element being processed. Within the loop, an if statement checks if the current number is even. This is done by using the modulo operator % to check if the remainder of number divided by 2 is equal to 0. If number %2 equals 0 evaluates to true, it means that the number is even. If the number is even, it is added to the sum variable using the plus equals operator. This operator is shorthand for sum equals sum plus number. After the loop has finished iterating over all the numbers in the list, the function returns the final value of the sum variable. This value represents the sum of all the even numbers in the list. Now let's illustrate how to invoke this function with a concrete example. Suppose we have a list of numbers defined as follows: list of numbers equals the bracket 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 close bracket. To calculate the sum of the even numbers in this list, we would call our function like so: sum of even numbers equals sum even numbers open parenthesis list of numbers close parenthesis. After this line of code is executed, the variable sum of even numbers will hold the value 30 because 2 plus 4 plus 6 plus 8 plus 10 equals 30. Finally, we can print the result to the console using the print function print open parenthesis sum of even numbers close parenthesis. This line of code will display the value 30 on the console. In summary, the SumEvenNumbers function provides a concise and efficient way to calculate the sum of even numbers within a given list. The process involves initializing a sum variable, iterating through the list, checking each number for evenness using the modulo operator, adding even numbers to the sum, and finally returning the total sum. This methodology effectively addresses the problem of summing even numbers in a list. To further clarify, let's delve deeper into each component of the code. The function definition def sum even numbers open parenthesis list of numbers close parenthesis establishes the function's name and input parameter. The parameter list of numbers serves as a placeholder for the actual list that will be passed into the function when it is called. The initialization sum equals 0 is a crucial step. It ensures that the sum variable starts with a clean slate free from any residual values. The for loop for number in list of numbers : is the workhorse of the function. It systematically processes each element in the list, allowing us to examine each number individually. The if statement if number %2 equals 0 : is the decision-making element. It determines whether the current number is even or odd, directing the flow of execution accordingly. The line sum plus equals number is the accumulation step. It adds the even number to the running total, gradually building up the final sum. The return sum statement is the culmination of the function's work. It delivers the computed sum back to the caller. Understanding these individual components is essential for comprehending the function's overall operation. It also allows you to modify the function to accommodate various use cases. For instance, you could modify the function to some odd numbers instead of even numbers, or to some numbers that are divisible by a different number other than 2. Now, let's explore some potential variations and extensions of this function. Firstly, consider the scenario where the input list contains non-numeric elements. To handle this, you could add a type check within the loop to ensure that only numeric elements are processed. This would prevent errors that might arise from attempting to perform arithmetic operations on non-numeric data. Secondly, you could generalize the function to accept an additional parameter that specifies the divisor. This would allow the function to sum numbers that are divisible by any given number, not just 2. This could be done by modifying the if statement to check if number %sign divisor equals 0. Thirdly, you could enhance the function to handle different data types, such as floating point numbers. This would require modifying the if statement to account for the possibility of non-integer remainders. For instance, you could use a tolerance value to compare the remainder to 0, allowing for slight inaccuracies due to floating point arithmetic. Fourthly, consider the case where the list is empty. In this scenario, the function would correctly return 0, as there are no even numbers to sum. However, you might want to add an explicit check for an empty list and return a specific value, such as none, to indicate that the input is invalid. Fifthly, for very large lists, you might want to consider using more efficient data structures or algorithms to improve performance. For example, you could use a generator expression instead of a list comprehension to avoid creating an intermediate list in memory. Sixthly, you could add error handling to the function to gracefully handle unexpected inputs such as none or a list containing invalid data types. This would make the function more robust and reliable. Seventhly, you could document the function using docstrings to explain its purpose, parameters, and return value. This would make the function easy to understand and use for other developers. These extensions demonstrate the versatility and adaptability of the function. By understanding the underlying principles, you can customize the function to meet your specific needs. It is also important to consider the efficiency of the code. The current implementation has a time complexity of O of n, where n is the number of elements in a list. This means that the execution time of the function grows linearly with the size of the input list. For most practical purposes, this is sufficiently efficient. However, for very large lists, you might want to explore more advanced algorithms to reduce the time complexity. For example, if the list is sorted, you could use binary search to find the even numbers more quickly. Another optimization technique is to use parallel processing to divide the work among multiple processors. This can significantly reduce the execution time for very large lists. In conclusion, the sum even numbers function is a versatile and efficient tool for calculating the sum of even numbers in a list. By understanding the underlying principles and exploring potential extensions, you can adapt the function to meet a wide range of needs. Furthermore, considering the efficiency of the code is crucial for optimizing performance, especially when dealing with very large lists.